going. So let's start. Okay, so we're just basically going to continue looking at examples. So once again, please, if you have other examples that you guys want to share, please do that. You can send me questions that we can put into this presentations, that we can work through some of those examples. So if you have any examples or questions that you're struggling with, please share those questions. So tonight we are going to look more at your first group of chapters. So we will be looking at anything from chapters 1 to 4 nearly. So that will be the focus of tonight, and then I will then, when we have our next session, I'll share beforehand what our focus will be, and then closer to your exam time, then it will be just simple random questions. Okay, so so a lot is nearly study units 1 to 3, but there might be some probability in as well. Okay, so and why I wanted nearly to go back to study unit 1, it was ages ago that we looked at this. So, and I think that is also important nearly for the exams, when you guys are prepping for the exam as well. Just remember how it normally is 25 questions, and those 25 questions is split up around 2 questions per study unit. So the latest things will normally be top of mind, but we are going back quite some time to what we started actually off in March. So just be cognizant of that. Okay, so let's look at this question. So, and let's just make that a bit bigger. Also, if I get disconnected sometime, I will reconnect. So just stay on the line if I get disconnected. Okay, so let's see what the first question. Which of the following statements is incorrect regards to variables? Okay, so remember way back variables, we nearly had 2 things that we said. There can be categorical variables, there can be numeric variables. We gave it other definitions like quantitative, qualitative. So let's look. Quantitative, okay, so quantitative variables take on values with equal units. Example, numeric values that indicate how much or how many. Okay, quantitative, quantity, how much, how many, that is correct. So how much it cost, how many a person weigh. So that is all numeric variables. Numeric goes with quantitative. So first one is correct. We're looking for incorrect, so we still need to go on. Variables can be classified as categorical and numeric. That's correct. Quantity, so quantitative continuous variables results from counting attributes of an element. Okay, continuous, you're not able to count. Okay, so this one is the incorrect one. If it was quantitative discrete variable results from counting attributes, then it is correct. But not continuous, because we can't count continuous. So continuous can be something like 1.3357. Somebody else have 1.71. So that is a continuous, so you really can't count those. Numerical variables, so numeric is, or it can be continuous or discrete. Okay, so that's actually the question. So numeric variables can be either discrete or continuous, which is correct. And then qualitative, so quality, variables uses labels or names to describe attributes of elements. And again, correct. So that can be the province where you stay. It describes the attribute. It could be eye color. It could be what shoes you're wearing. So all of those things are describing the elements of the element. So for this one, we needed to go back to chapter 1, where we looked at the differences between discrete, numerical and um, categorical data, or basically qualitative versus quantitative data. Okay, so that's nearly our first look at that component of study unit 1. And then the other one is where we still look at study unit 1 around variables, is we go into scales. So, and scales is basically a method of giving more information about the variable. So you can have nearly, that's the next level of data. So let's look at the question first. Which one of the following statements is incorrect regards the scale of measurement? So a nominal scale of measurement is the weakest form, while ratio scale is the strongest. Sure, I remember we had that in our first study unit. We had a table like that. So nominal is the weakest. So nominal means there's no rating. It's just like province or something like that. Ratio is the strongest because ratio has a scale that goes negative, turns positive, or is 0 and turns positive. So that is the strongest form of a measurement. And a simple example of a ratio scale is temperature. So you can go into negative, you can be 0, and you go into a positive temperature. So a simple example of strongest ratio scale is temperature. A nominal scale measurement, province. So province doesn't say anything. It's different if we add to that a ranking, which will be your second weakest. But so if we set um, according to Olympics results, which country have won the most medals, second, third, and fourth, then there's a ranking. Then it becomes something different. So that first one is correct. We're still looking for the incorrect one. The next question, the mean and the median cannot be determined for a nominal scale of measurement. Okay, so if we had province, we can't say what's the average province. You don't, unless you have something specifically that you measure within the province. But just to have province, you don't have a mean, you can't have a median. So the mean and median cannot be determined for a nominal scale is true. Okay, the mean and median can be measured for a ratio scale. So if I had the, the temperatures for June, I can work out what's the mean, I can work out what's the median, but not the same for the nominal scale. Quantitative, so again, quantity. So quantitative continuous variables result from measuring attributes of an element. Okay, measuring. So it's true. So again, measuring temperature can actually be a continuous variable as well. If you need to measure distance, that's also a continuous variable. Ordinal scale of measurement is higher level of measurement at interval. Okay, so that is wrong. So just to get the scales, and again, remember, you are writing open book, so you can use all the slides that we have looked at, but it's normally nominal. Then you put order to it. Then you put the next one is interval, and then you do ratio. Okay, and it is in our study guides. I think it is, let me quickly copy that image when we have it also in here. So I'm gonna put that here at the bottom. Okay, so it is something that we have in the slides as well. So you can definitely, again, please remember, you are writing open book. So there's certain things that you can just use. You don't need to worry about it. Then the last one, let's look at the last one. Quantitative, so again, quantity, discrete variables result from counting. So this is actually a nice slide to also have with you maybe when you write the exam, because it's nice to have the discrete with the counting, the continuous with the measuring. It might be somewhere else as well, but here you have it in a question, so it can actually be used quite nicely. Okay, so let's look at the next one. So basically the first one was a bit around the types of variables, then scales of variables, and then this one feels like a combo of that if we look at this question. So let's quickly. So the majority of rural schools in South Africa are in Eastern Cape, KZN, and the Limpopo province. The basic Department of Basic basic education requires your assistance in gathering some of the information to effectively manage the scholar transport system in some of the rural areas. Which one of the following statements is, again, incorrect? Also, just, again, a note that just be very careful in the exam. It might be that they do the incorrect for 3 questions and then suddenly change it to a correct question. So just be again very careful in the exams when they phrase these things. So which one of the following statements is incorrect with regard to types of variables? Okay. The age at which learners first enroll at a school is a quantitative continuous variable. Okay, so quantity continuous is correct. And the reason why is they don't ask you age in years. So it might be that I know I registered my son um, when he was like 5 or 6, and how many months and how many days. So somebody else could have gone in the next day. So age in this instance, because they don't define it as age in years, it is a continuous variable. Okay, so the same should be for travel time. If I said to you travel time in hours, then we know it is discrete. But else, travel time from a learner's home to school, quantitative continuous is correct. Because again, one child's travel time from the other one will be different, and how they report it might also be different. Um, the number of schools, okay, so that tells me it should be discrete, um, because they say the number. So if I say the number, you know the number must be 1, 2, 3, 4, 5, 6, or 7. So the number of schools requiring learner transport, quantitative discrete, which is correct. Whether or not a school is classified as a special needs school is qualitative. That's correct. Nominal is correct. So there's not a rank between a special needs school. So it will be, is it a special needs school? Yes or no. So there's no order in that. So that will just be a nominal variable. The size of a bus, small, medium, large. So that tells me there is a rank order. So it is qualitative, but there is order. So it should be qualitative ordinal and not qualitative nominal. So that is the incorrect one. So for this one, nearly it is just, it takes time, but one needs to nearly work through the questions to get to, and unfortunately this one was the last one. So again, there's no like quick, easy way to identify in some of these things which is wrong and which is right. Okay, so some of these are just, unfortunately, you need to work through it. Yeah, so this is, some of it is past exam. These are also past assignment. So these are more past assignment slash mock exam questions. So it's more mock exam than past exam. Um, there isn't really any past exams going around since they went online. So if anybody has access to um, some pictures of previous exam questions or anything like that, you more than you can please share that with me, because I will then work through it in these sessions. So also, if you have other previous exams, previous assignments that you want us to work through, by all means, please share that with me, so that we can cover as much of anything that is possible for them to ask. Okay, so let's look at the next one, because I thought this was also quite interesting in how they ask it, and it's very much, again, if one takes this scales of measurement, we can actually use that in here as well. So again, you guys don't always need to remember it like in off by heart and being able to, okay, it's very small now, but it's just so that I will also share the presentation with you guys afterwards, when you have it as well. So some personal and school related information um, was collected on learners requiring scholar transport. Variables 1 to 5 below shows the collected information. Then they ask us for which variables is it possible to determine median. Okay, so there is median. So when we look at median, it's possible for ordinal, let me quickly do that. And let's just do, so if we look at median, it is possible for ordinal, interval, and ratio. So if we can identify those, then we can identify which ones is right or wrong. And here it might be that we can already identify the right answer by just eliminating a few. So progress at school, satisfactory and not satisfactory. Okay, so satisfactory, not satisfactory is ordinal. Ordinal, we can work out a median. That's interesting. Oh, sorry, it's not ordinal, it's nominal, so it's yes or no. Um, so there's, sorry, I misread that one. Um, it is nominal because it's just yes or no. So there's no order in satisfaction. It's not that it's less satisfied to completely satisfied. So there's no order in option one. So it's just nominal. So we can't. So let's look at, okay, there's option one. So it's not A. It is possible to determine the median for all variables. Okay, no, it's not for one. Okay, not for one. Only one. Okay, so in this one, by just identifying the first one was wrong, we actually then have our answer as option E. Okay, we didn't even need to look at if options 4 and 5 or it's correct. But let's quickly look. Sex assigned at birth, female, intersex, and male. Okay, so there's no order in that. So it is nominal. List of subjects enrolled for. So again, there's no order. So if you have stats, economics, accounting, there's no order in that. Number of subjects enrolled for. Okay, so one of you guys might be enrolled for 1, another one might be enrolled for 2, another one might be enrolled for 4. So that is ordinal, and we are able to work out the median. So we can work out what's the median of subjects that class is enrolled for. Emotional intelligence, or a EQ score. Yes, we can. So everybody has a different score. We can work out what the median is. IQ score, yes, again, different scores, we will be able to work out what is the median. So 4 and 5 is correct. So option E is the correct one. Okay, so let's look at the next one, and then we might be starting to go into chapter 2. So also, I think what's important for you guys, and I will share more of those questions that nearly, so as we will work through questions, I will include those as well. That's nearly moving between two study units. So because there can be those questions as well that, like we now did this one where you look nearly at study unit 3 with median, mean, and mode combined with study unit 1. So it might be that we need to look at some other questions that does that cross section as well. Okay, so which of the following statements is again incorrect with regard to tabular methods for summarizing data? Okay, incorrect one. So the percentage is equal to the relative frequency multiplied by 100. Okay, so you have first your frequency, then you will have your relative frequency, and then your relative frequency times 100 will give you your relative frequency percentage. So that is correct. Cumulative frequency distributions are tabular methods suitable for summarizing quantitative data. Correct. So quantity you count, so then you will be able to summarize it in bands. So again, if we looked at how many subjects, we could have said students with 1 or 2 subjects, students with 3 or 4 subjects, students with 5, 6, and then you can do summaries on that. So cumulative frequency is available if you do quantitative. Frequency distribution, relative frequency distribution, and percentage frequency distribution are tabular methods suitable for summarizing both qualitative and quantitative. So let's say we've got the number of people in each province, then we have a frequency distribution, which is fine. We have the relative frequencies, so we can say the decimal nearly of how many is in Gauteng versus Western Cape. And then we have a percentage to say 30% is in Cape, 60% Gauteng. So that can be done on the qualitative side, and it will definitely be available to do it on the quantitative. So quantitative, you can even do more, but for qualitative, that is the free measures you can do. Then to create a frequency distribution of qualitative, we first need to define non-overlapping classes by determining the number of classwork, etc. That one is incorrect, but because for qualitative data, we will never have to do that because it's around quality. So it's about, so again, province, there's no overlap in provinces. There's no overlap in eye color. There's no overlap in, so yeah, so that you don't need to look at classes for quantitative data, yes, because where you will have a minimum, you will have a maximum. You need to decide how many classes, what the class width is, all those kind of things, but not for qualitative. Quantitative, yes, but not qualitative. And then cross tabulation are suitable for summarizing relationships between two variables. Correct. And now look at that we did in study unit 10 as well. So we never, when we did study unit 2, thought about where we're going to use it again. But everything in study unit 10 about chi-square, that is all about summarizing the relationship between two variables. Okay, so then we probably will move now much more. Yep. And I think this question has been in so many assignments since post-COVID, so many mock exams or mock assignments. So it just tells us that you will get something similar like this. So on that note, it will also be good if the 1510 students can share some of the questions they had across the last couple of assignments, so that we can bring that into this as well. Also, just for 1510 and 1610, you most likely will have different exam dates, but also we will plan accordingly. So if 1510 is before 1610, we will work in extra sessions before you need to write exam. Is 1610 is before. So for both of the two subjects, we will have sessions just before the end of your when you need to write. So don't worry that if 1510 now has done the exam that we stop, or if 1610 has done the exam we'll stop. We will continue with sessions until both of you are done with your exams. Okay, so consider the following cumulative frequency. So you can see there is class width, there's cumulative frequency given. So they might ask us certain questions to work out the frequency. They might ask us to work out the width of this class. So there might be different questions. So let's look at the first question, the percentage frequency. Okay, so not cumulative, percentage frequency. So first we need to check how many students are between in this one class 9 and 10. Okay, so if we look at the first one, between 4 and between 6 and 8, there's 4 students. So between 9 to 11, it's 17 minus 4, which is 13. Okay, so if we need to work out the percentage frequency, it would have been 13 divided by the 50 learners, which is equal to 26%. Okay, and not 54. So if this was the exam, you got the first one is the incorrect one, to go on. Please don't look at all the other questions and see if that is also, because again, exam, if I think it is still like that, it's only 2 hours for 25 questions. So it is, you need to, with some questions, need to nearly gain some time. So if this was an exam question, pick it and go on. Okay, so but let's look at the midpoint. So how do we work out the midpoint? So we will take the 2 bands, so over 2 points over 6 and the 8, and we will divide by 2. So the midpoint would have been 7. Okay, so that again, we're looking for the incorrect one, which was that first one. Relative frequency of class 18 to 20. So again, relative, not cumulative. So if we look at how many students were in that 18 to 20, we could have said, well, 50 minus 48, that is 2 students. So 2 divided by 50 will give you 0.04. Okay. Then the width of each class. So we include 6, we include 7, we include 8. So because it is 6, 7, and 8, it is 3. So just remember in that 8, and it might even come out again, I think this was from also previous assignment, that 8 includes 8.9. So it's not just 6 to 8, it is actually 6.000 to 8.9999. So that's why also we look at the width to say it is not just 6 to 8, and that's why it's only 2. You're actually including a lot of other numbers after 8 as well. So you can nearly say how we work it out is rather to say 9 minus 6. That will give your class verb. Okay, and then the frequency, so again, frequency of class 15 to 17. So that would be 48 minus 42, which is 6, which is correct. Okay, so just needed to go through the other questions to show you how that is also done. Okay, so now you can really see this was actually the data that was summarized in this format. So if you look at between 6 and 8, there's 4. So let's just quickly show it. 6, 6.47, there's 8. So there was 4. So again, just a way of showing how a data set like this can be summarized into something as small as table 1.1. Okay, so one of the nice things here, they already tell us the data is ordered. Okay, so again, just be careful when it might be that they want to catch you out, which unfortunately nearly it seems like all the decision sciences and stat modules, that is part of it. So if I don't say it's ordered, please just make sure it is, because it might be that they start off with the data as ordered and somewhere in the middle they change it up a bit. So again, just be very careful when you are getting a data set that you are 100% sure it is ordered. So they tell us it's ordered. They will not tell us it's ordered and then do something different. So they tell us it's ordered, so we know that the smallest distance or the shortest distance is 6.2 and the longest distance is 20.2. So again, if we needed to work out the range, 20.2 minus 6.2 would actually give us 14. Okay, so I'm actually now answering one of these questions already. What did they want us to do? Again, incorrect one. So unfortunately, that is not the incorrect one, but just showing again, biggest minus smallest give us the range. Okay, then let's work through the questions. The position of a first quartile is 13. Okay, so if we look at how to work out Q1, Q1 is, the formula is n plus 1 divided by 4. Okay, so n plus 1, in this instance, they did tell us there's 50. So 51 divided by 4. And then remember that we round it off. So we round it off. So it would have been 12,75, which will then give us position 13. So the position of a first quartile is 13. There it is. So if we needed what is the number of Q1, it would have been 11. Then they tell us the position of a second quartile is 12.5. Okay, so that we can just see it's incorrect. If your first quartile is 13, your second quartile can't be 12.5. So it is probably the value of 12.5, but let's quickly check. 2 times n plus 1 divided by 4. And so that would be equal to 25.5. So between 25 and 26. So between 25 and 26, the value is 12.5, but not the position. So that is why that one is incorrect. And then they nearly repeat it, but say the second quartile is calculated as the average between 25th and 26th observation. Again, that is correct. That is also your median. So again, just they haven't asked it, but your quartile 2 is the same as your median. And then position of a third quartile is 38. So let's just quickly work that out. Quartile 3 will be then 3 times n plus 1 divided by 4. And that will give you 38.25. And then again, we round it off to the nearest number, which is 38. So again, if they ask us what was the value of Q3, so the position is 38. So if I wanted us to say what is the value would have been 14. Okay, so just again, important to remember the difference between value and position. This question was fully focused really on anything that has to do with the position of Q1, Q2, and Q3. So again, it might be different for the different questions, where the next set of questions could have been to the exact same data set, but they could have in each one actually ask you what is the value of Q1. And then they might again change it up to say the value of the first quartile is 13 and it should have been 11 to get you the incorrect one. So just again, remember that these questions might also be different for the different, there is again 2 or 3 different exam papers with different questions. It's not going to be that drastically different. So it will look at the same type of question where, again, they might just now change some of the values and the positions so that you pick a different answer. So it will not be now suddenly it is a totally different question. Okay, so I will also just make a note now that I think about this, with IRIS being again your method of, so in your assignments you were allowed to go back to previous questions. In the exams the last couple of years, the guys were not allowed to go back. So I will just go and ask the lecturer about that. Because again, if you now look at this question, some of the previous information would have been nice to now have had access to. because now that we need to work out interquartile range, I wanted to know what was Q1 and Q3. So that was Q3, that was Q1. So then it's easier to say, and let me just quickly, can you guys still see my screen?
Yes, we can.
Yeah.
Okay, cool. Okay, so it would have now been nice to have access to this to say, well, it's 14 minus 11. So again, I will check for you guys just to see with the lecture if how that will pan out. So again, you don't now want to go back and say, okay, for interquartile range, I need to get Q3 minus Q1. And now you don't remember what it was, and then you might guess. But we know it was the position 58 and position 13, so 14 minus 11 was 3. Okay, there is no mode. Okay, so there's already a mode. So there's 9.1 and 9.1, so there's already a mode, but it might be more than one mode, so let's just check. The others, so there is another mode, so it's basically bimodal, your trimodal. Okay, there goes massive. So 12.5 would have been the mode. There will not be another number that is repeated so many times. So what was that? 1, 2, 3, 4, 5, 6. So 12.5 is the mode, if we wanted to know it. The mean is 12.5. Okay, so luckily they tell us here the sum of all the observations has been calculated. So 626.6. Let me quickly see. Do I have? So 626.6 divided by 50. So that gives you 12.5. So that is then correct. So again, for this one, they would not now not give that number, because they will not expect you, if you need to work out the median, the mean, to now go and add all of these numbers. If they wanted to do that, it will be on a maximum of 10 numbers. They will not give you a data set of 50 numbers and expect you to work out the mean. So they will give you information to make it easier for you to work it out. The median, okay, so we already said the median is between 25 and 26. So that is 12.5. So then if we see the mean, median, and mode, so now we go to even normal distributions. That was just chapter 6, 7. When we had mean, median, and mode the same, we knew that the distribution was symmetrical. So the distribution of a distance from home to school is symmetrical. So we did, if you can remember, we did that part in study unit 6 and 7. We did it in study unit 3. So again, some kind of similarities. So they might also, in a question like this, ask you if the data was now different, if it is positively skewed, if it is negatively skewed, or they could use the other two where it is left skewed or right skewed. So just remember all of those other symmetries that can be asked or reflected in a question like this as well. Okay, so we nearly go back to this was a summary of the data. Then we went into some work around the quarters. Then we went into looking at the the measures of location, so mean, median, and mode. So the logical next question will probably be something to do with standard deviation and variance. Okay, so here you can now see that that is how they went above it or about it. And again, they're not going to give you this information without giving you something else. So here they give us the sum of squared deviations around the mean. So it has been calculated for you. So you could have gone to say, okay, if I need to work out the variance and the variance of the sample, because they tell us it's a sample. So remember, then variance will be 406.369 divided by n minus 1. So remember, for sample, it is n minus 1. For population, it will just be Pn. So 406.369 divided by 49 gives us a variance of 8.293. So let's quickly check. That is sample population. Sample variance. Sample variance 8.239, which is correct. So if you take that 8239 and you take the standard or the square root of that, you will get the standard deviation. So that square root will give us then, if we just do that, we will get the sample standard deviation of 2.880. So those two are correct. The other one that I say the variance is equal to the standard deviation squared. Cool, that is also correct. So then we need to look at the population. So population variance and population standard deviation. So if I look at the population variance, again, it would be that same number, the 406.369, but this time divided by 50, because that is what the population standard deviation will be. So 406.369 divided by 50. And that answer is equal to 8.127. Okay, and that tells me then, okay, so here they made a mistake. It should be 8.127, not 7.127. So option A is the wrong one. And then if we take that and we take the square root of that, we will get a population standard deviation that is equal to 2,851. Okay, so again, it will be very similar in your exam. It will, the one question, it will follow on one another. So you will not start off with the the variables question and then jump to regression and then jump to um, confidence intervals, then back to probability, and then so so your exam will follow like your study units was. So question 1, 2 will be on study unit 1. Question 3, 4, study unit 2. Question 4, 5, study unit 3. So you will get that sequencing in your question. So you don't need to worry that suddenly there's a confidence interval, then you back to probability, then it is regression, then it is something else. So it will follow. So that's why um, you guys could nearly have seen how I said it. Okay, here we did chapter 2. So you move into chapter 3, you look at the positioning of the numbers, then you go and you say, okay, the positioning, so that's all about measures of location. And then the next part of study unit 3 is measures of spread. Okay, so that is your variance and your standard deviation. Then what they might ask as well is what is that variation one? And here it is, coefficient of variation. Um, they might, now they give us new data, but they might have done it on this data as well, because we know that the coefficient of variation, um, you basically need to have the standard deviation and the mean. So in both of these questions, we actually have worked out what is the standard deviation and the mean. So again, it could have been that this question is also based on those previous data sets. Okay, so let's quickly check coefficient of variation. Um, so when we look at this, I am not by hand going to work out what is the mean and the standard deviation. So I will quickly put this data in Excel. So again, it will be a clean spreadsheet because there is not even a function like coefficient of variation in Excel. So I would just put in, and I'll share my spreadsheet now, 100, 104, 110, 111, 112. So let me quickly just share the spreadsheet. Okay, so let's see if I can just, okay, so there was your 5 data points. So I know that I need to get the mean. There isn't a mean function. So the mean is the same as the average. So I will work out what the average is. Then we need to also get the standard deviation. Remember, it is a sample. So we need to get the standard deviation of a sample. And then how we will work it out is let me quickly just check. I must first go and check what is the formula. because I always had it as standard deviation over mean. I might be wrong. It might be the other way around. So let's just make 100% sure what that formula is so that I don't make a mistake with it. And it was chapter 3. Copy. We'll put it on the slide. Let's put it in here as well. It doesn't need to be that big, sure. Okay, so standard deviation divided by the mean, and because you need to multiply by 100, and that will give us 4,82. Just check, so that is 4,82. If we did not do standard deviation of sample, but we did it of a population, it would have been 4.3. So let's just look at the answers when we go back, and let's just check that there is hopefully not a 4.3 as one of the answers. So okay, so luckily not. So there's the 4.8. That is the correct answer. And luckily there isn't the 4.3 that we had as an option if we worked out the standard deviation for the population. So that at least is comfort in this one, that it did not do that. Here you can also see there was the sample mean that we worked out. There was your standard deviation, and that will probably be your standard deviation square if I look at, no, it won't. No, it won't. So let me take that out. Okay, so your two numbers that you needed to have was also in here. So again, sometimes they might even give you in the question, they might say you have a standard deviation of a mean, of a population, you've got a standard deviation of a sample. They give you the sample mean, and then they ask you to work out the coefficient of variation, so that you need to know which one to use. Okay, then we have this question around your 5-number summary, which is also the same as your box and whisker. What else do they call it? So that's basically what we normally would have is your minimum value, then you have your Q1, then you have the median slash Q2. Let's just assume that's a box. Then you have your Q3, and then at the top you've got your maximum. So let's quickly check. You've got a minimum value, that's right. You've got a maximum value. That's right. You've got your first quartile. Correct. Third quartile. Yes. And then your fifth measurement or your fifth number would be your median or Q2. So it's definitely not the coefficient of variation. But again, how easy one can make a mistake, because you basically have now just done coefficient of variation in the previous question. So it might even be that now triggers that you only look for, or you say something different. So again, be careful, because it might just be that one question was now the one that they want to again try to catch you out. Okay, so let's look at the last question for tonight. So we look at, and I think we've done this one a few times already. But what is interesting is when this was also in one of the assignments, um, the question, the data changed. So for this one, we see that is our minimum, 115. That is our maximum. So what I would first do is I would look at minimum and maximum of all of these three. So I would go and say 115. So yeah, I'm like, okay, that's 100, so it's not A. Yeah, I would say, okay, that's 80, it's not B. Again, 100, not C. Okay, 75, not D. Okay, if that looks like 110, that is a possibility. And then I look at this and it's like, okay, that's around 90. Okay, also not. So actually, by just looking at the minimum, I have identified that E is the correct answer. Okay, then please again, what you can quickly do is to say, cool, E, you go to the next question. But E actually references box plot B. Okay, so it's not box plot B, it's not box plot F, it's not box plot C. We're actually looking for box plot E and not the other two. So again, just be very careful. Exam, you are under stress. You are working against time, and this is a very easy one just to make a mistake. Um, let's just look at the other numbers. So 150 max. If I look at that, yes, that looks like between 120 and 140. Then Q1, because there's only 5 data points, that will be Q1, that will be Q2, and that will be Q3. So Q1 and the minimum is both the same, so that is where they will lie. Then you have Q2 is on 120, Q3 is there on 125 with the maximum. So definitely E is the correct one. Okay, so that again is just nearly coming from the previous question where I talked about the 5-number summary. Then we go into the data with the 5-number summary. So what also happened, you can nearly look at, this could have been also the data set. So let's look at a minimum where it was 100 and maximum 120. 12. Let's just quickly check if there was one. Minimum 100. So here was a minimum 100. So might have been not. There's a minimum 100. Might have been not. So here you could see that could have been some of the information, but there, both of them, they go to 140. So obviously that data was a bit changed to get these data sets. But if I look at C, so what would have happened in C is our smallest number is 100. So if I needed to do the 5 numbers, it would have been 100. Then my Q1 would have been, looks like 110. Then my Q2 and my Q3 would have been 120 because they both on one number. And then the 140 would nearly be seen as an outlier because all your other data is lying in this space. So that would have been the data to E. So just, you can also look at the other box plots and look at how you would have looked at that data. So here again, you could see that's probably now around 90. So there at 100, you can see it's nearly a double line. So there would have been your two numbers at 100. There you would have been your Q3 at 150, and there would have been your top number at 140. So where there are these double lines, you can nearly see. So there it was Q2 and Q3 together. There it was your minimum and Q1. Here it was that Q1 and your median were the same one. Okay, so that is it for tonight, everyone. So that's a good nearly reflection of study units 1 to 3. So the next session, I would want us to nearly focus on study unit 4 and 5, but it might just even be 4. I think the probability one is very important. So it might be that we do most of a session, the next session on probability, and we might start with study unit 5, but yeah, want to do really a big session on study unit 4 probability, because I want to get into all the different probabilities again. Want to show how some of the conditional probability works when you get a table with numbers versus a table with some probabilities already in, how to work that out and things like that. So yeah, the next session, most likely only study unit 4, but we'll check. It might be that we do 1 or 2 questions on study unit 5 as well. But I think the next one, study unit 4, and the session after that, then we can again focus more deeply into study unit 5. So let's do it 2 sessions. Next one, study unit 4 on probability, and then the session after that will be on study unit 5, where it is all those discrete binomial Poisson distributions that again we go into more detail around that. Okay, thank you everyone. Have a wonderful evening. I will see if I can, hopefully we'll put the recording on as soon as possible.